seems to be interesting in this context is this. Whereas all the music, even the music of Beethoven, up to that historical moment, had been made by using certain formulas, objects, like a theme or a motive, and transform this object, vary it, transpose it, put it into sequences, even destroy it or develop it further. In the music that was written up to since 1951, there was an explicit spirit of non-figurative composition. We tried to avoid all figures that were recurring, which means all repetitions. And through this, something became very clear, that the way sounds were organizing themselves, or were organized, was the most important, and not the particular formula that occurred in a given moment. The fact that certain notes were composed as points, others as groups, that was the essential. So whenever groups would occur, points would occur, that was the recognizable element. Whereas these groups could be completely different, renewed in their intervals, in their shape. And the points could be somewhere else, in a different region, and of different overall quality, generally shorter or longer, or higher or lower. Being points, that was the characteristic. Or being groups, or a mixture of both. So I said it once in the following terms, whereas in traditional music, there was always, at least in the best, the best composed music, let's say, in a development movement of a first sonata form, movement of a Beethovenian composition after about Opus 50, where increasingly the through composed, the Durchführung, the through composition, the development became important. But the development, you say that, became more and more important. There's, as you know, the Fifth Symphony is always quoted as the most important. There is just one formula, which is present all the time, like in a kaleidoscope. That in the music that I'm describing, there was always the same object shown in a different light. Whereas since 1950, there were always new objects shown in the same light. And that is something completely different. So naturally it wasn't just one light, though yes, because I used, for example, one row of proportions for all the characteristics, for durations, for pitches, for dynamics, and I still try to find a unifying proportion, a factor for proportion for a given word, like in mantra, which is the last work that I composed through, so to speak, with total development, with total through composition. Can you say that? Total through leading of a formula. What? You know it, you should know. Which means there's nothing present, but all the time, for 63 minutes, the mantra, the 13-note formula, in different expansions and contractions, in 12 degrees, but it's always the same. Always new objects in the same light, and the light that's, for example, that series of proportions, which gives birth always to new phenomena, musical events. That's interesting. And then in an increasing way, music is going in that direction. But the unifying factor is underlaying all the different events that occur. And one shouldn't be trapped too much by the events, but feel that and discover that underlying proportioning principle, the genetic principle that gives birth to all these different musical events. You heard already in Brooklyn several crowds of notes, as I might say, or collective in sociological language, or let's say masses of notes, where we cannot count the individual notes anymore. They go beyond the group. And I always say, in group playing, for example, if someone wants to join in when we play in our group, and I say, well, 5 is good, but 6 is already dangerous, and 7, with 7 the mass begins. Because then completely different relationships between human beings start to act. I say, when we cannot count any longer the elements. So this depends on the speed. Naturally, if it's too fast, we can't count them anymore. And 30 notes may just occur like a gesture. And one doesn't feel like as if one should count them. Or they're just too many superimposed, like a swarm of bees, where you perceive the shape of that swarm. It becomes one again, like a tree. You don't count the leaves, but you can very precisely see that's a pine tree, not a beech. It's because of the elements. But there's something else, that is that shape, that overall form. That is true for a mass. So for the first time in the history of Western music, composers became involved with the composition of masses of notes. And I still remember a moment during my musical education at the conservatory in Cologne when I had sometimes, it was a kind of an essay, an exercise. I didn't think I would ever become a composer at that time. I showed it to my teacher when I had composed very many notes in a small amount of time. Then he said, who is going to hear them? Who can hear these notes? You don't control what you are writing. You see, what is the point in writing notes and if the people can't hear them? I said, I don't want you to count them. He says, well, what do you mean? Look all these notes here. I said, yeah, I want this. He said, well, just make one note, be precise, and that's it. So it was unthinkable. And at that time, in order to justify what I was interested in, I did an analysis of Debussy music, of Jeu. And the program was called Statistical Characteristics in Jeu of Debussy. You can imagine and I was speaking about trends in register of certain textures, about trends of density, increasing and decreasing densities, overall densities, of predominating colors from dark to bright, or from metallic to muted colors, etc. I was inventing a complete new language. Or I was speaking of perforated music textures. I used the word textures as being opposed to structures, etc. And I spoke about rising shapes or drip form shapes, etc. Or sawtooth shapes of masses. But you can imagine what I'm talking about, actually. What is a sawtooth? There you are. I make here 300 notes in 2 seconds. That's what I want. It's quite different from another one, which I make then, which has, for example, such, not a sawtooth, let's say, but a shape like a sine wave. And I'm speaking of pitches. High, low, high, low, high, low. Here too. And then I would make in here more sustained notes. It's quite different from this one. See? Or notes which have this characteristic here in this one. And here I would make all trills. So I give it a certain texture, etc. I remember in groups for 3 orchestras already, I was sitting in a room in Paspels, close to Chur in Switzerland, in a room for 3 months. And I had a small window, like this, in front of my desk. And I saw these incredible shapes of the mountains on the other side of the valley. And there are quite a few groups for 3 orchestras, which have exactly the shapes of these mountains. Where, for example, I have become a specialist in drawing such curves at that time. And then I would fill them out. For example, I would subdivide it in musical durations of equal duration, what I call like fundamental durations. Let's say these were whole notes. Then I would subdivide here. Let's say here is the form, there, goes here, etc. So higher and higher forms like overtones, but we are speaking now of rhythm. And this were a subdivision by 2, this by 3, this by 4, this by 5, etc. This by 6. But you see, I could also, sometimes I like to make windows inside, where there was nothing. I left it out. And I started to think in shapes of musical masses, of sound masses. So we will come later on to the term statistical methods to compose masses. I play you now the end of Song of the Youth, a work which I realized in the studio of electronic music of the West German radio station in Cologne. And the process with which I realized this work had become already statistical. For example, I would give to 3 collaborators a sheet of paper and I would say 20 seconds. And the second one, and the third one. All 20 seconds long. In order to make a certain sound event. And then I would say, during this time, you go with the speed of a pulse generator, which produces electric pulses. Like this. And you start with 4 pulses per second, and you end up with 16 pulses per second. And for the second one, I would say you use a dynamic control device with a geometry. And during that time, you do this. This is maximal, and this is the minimum of dynamic. Let's say this is the range, as we say in technical terms, of 40 decibel, which you can see on a decibel counter. Then to the third one, I would say you use the electric filter, which filters these pulses. Do you understand what I'm talking about? This is, for example, the 4 per second, which is up to 60% with a pulse generator. And this again is fed into a filter. And the filter would have another curve. Let's say it would start at 4,000 cycles per second. Cycles per second. Excuse me. CS. And here would be 1,000 cycles per second, to make it very simple. Then he would have to make a curve like this. Excuse me. Like this. during that time, 20 seconds, then we had a stopwatch, a big stopwatch. We started. Then at 3, we started doing these curves, and we made several examples until when everybody said, all right, it's fine with me. You too? Yes? Okay. Then we would make, according to my definition, 7 layers, all of 20 seconds, and in each layer these curves are a little different, and then superimpose them all. Actually, I can't say in which moment exactly a pulse will occur. Only the tendency I can indicate, following this curve. And the same is true, I can't say exactly at which side of the second you will be during this time. And the same is true for the dynamics. So if you superimpose then several curves, let's say a second curve which goes like this, and the third one which goes like this, then you get the result of many different curves when you superimpose these 3 layers, 4 layers, 5 layers, 6 layers. The number of layers and the overall tendency in each using characteristic then leads us to a certain result, which is a mass. And it has a very precise shape and a very precise tendency compared to another mass. And this composition of musical microtextures with statistical methods then has become very, very important in music in many different ways, and all the so-called chance operations in music are nothing but that. Already in the early 50s, and I studied again after having finished my music studies at the University in Bonn, communication science and phonetics. The simple analysis of noise sound, of the wave structure in noise sound, just led us automatically to statistical wave structures. And when I enlarge into a larger time, what I find in a single sound, like in a certain consonant, then I get entire musical sections which have the same behavior, like a single noise. I think the most important discoveries in the different fields of musical thought, let's say everything that happens between 8 seconds and a quarter of an hour and half an hour in music. And in rhythm and meter, everything that happens between 1/8 of a second and 1/16 of a second and 8 seconds. And everything that happens in harmony and melody, everything that is organized between 1/16 of a second and about 1/4,000th of a second. These 3 regions are all interrelated. And it's interesting that when one would be able, and one is nowadays able, almost able, technically, to stretch a single sound into half an hour, a sound which lasts, let's say, 1 second, stretch it half an hour, then you have an overall form which has the characteristics, the subdivisions, etc., of that single sound. Or if, on the other hand, you are able to compress the whole Beethoven symphony into half a second, then you have a new sound, and its inner microstructure has been composed by Mr. Beethoven. But it has a very particular quality compared to the compression of another Beethoven symphony, not to speak of a Schoenbergian symphony, because there will occur many more aperiodicities, so the Schoenberg music will be more a noise. And the Beethoven music will be a vowel. Because it's periodic, based on periodicity. Let me play now the last part of Song of the Youth as one example of mass structuring. Naturally, there occur also groups and points. That's always the case. The same that I have said about the point composition, I could also say about the group and in particular about the mass composition. It would be desirable that the music that is composed the precision of the masses, the shapes of the masses would increase, that we would know better how to determine precisely certain tendencies in masses of notes, and we have very little experience in that field. We have even done no research. Me as a composer, for example, I go on composing, but I have not done any systematical research, and it would be necessary because in other fields I am working with very precise measurements, but I have no precise knowledge of certain shapes, of the behavior of certain shapes in certain contexts. I just do it intuitively. And I don't deny that I make many mistakes, where when I try to combine points with certain masses, then the points are completely covered. Or when I think there is a difference in certain textures within masses, they don't come out. Then I make mistakes in speeds, primarily in speeds, where I think there are still differences recognizable at high speeds. When I come to the performance, they are not. Then I have to change a lot during the rehearsals. And when I have to talk about it to other composers, or let's say to younger composers who want to work with me, then I know very little. My language is not developed to speak about these things. I use mainly words then from statistics that come from other fields. Now we come to the second set of terms. Determinate, variable, and statistical. This is the way how points, how groups, how masses can be composed. I can compose actually points in a very determinate way. Groups in a determinate way. Masses in a determinate way. What does that mean? It means that I can very clearly hear the intervals, which means the proportion. I can hear very clearly the duration of the individual points, groups, and masses, their shape, etc. So I don't really need to give examples for the determinate way of structuring points, groups, and masses, because all the schools, up to 1955, 6, even of that new music, have been completely notated. All the characteristics have been determined in terms of classical scales and measurements. But a new phenomenon was the method to compose variable structures. What does that mean? I give one example, then I leave it up to you, to your imagination, to invent many more. I composed the word Zeitmaße, time measures, for 5 woodwinds in 55. It was at the same time when I composed some of the youth in the studio. It was for 5 woodwinds, traditional ensemble. But in that word, determinate structures where you hear very clearly the individual notes, groups, sometimes masses of notes, are alternated with variable structures. For example, there's a point where all 5 instruments start together. They have played chords before. Everything that is vertical is clearly determined, because never notes would fall just by accident together in a chord. Like, well, you don't need to go into detail. That is, a chord, and in particular sequence of chords, is always it's a clear sign of determination. And in particular, if there is a progression from chord to chord, let's say from more simple to more complicated chords, and back to more simple ones, like in the classical harmony, from consonant to more dissonant chords, and back to consonant. This is always the sign for high determination. But I say, when it happens and follows that there is a point of departure, and then every instrument starts playing in different speed. So the oboe, for example, is playing as fast as possible to give us a number of notes. The bassoon is playing as slow as possible, so it captures all in time rate. The English horn is playing from as slow as possible to as fast as possible. What does it mean as slow as possible? For a woodwind player, I write, for example, a number of notes and play it with one hand. And I play it as slow as possible. Actually, that changes with the size of the lung of the player, but that's not what I mean. But yes, there is a clear determination for that one player. Then another player plays start as fast as possible, and it says slow down until you reach a speed which is 4 times as slow. And then after a longer time, after some time, when everybody has played the notes they were written, they meet again, they wait for each other, and they meet again at the same time, in metronomic time. And that is clearly marked then when the groups follow each other in a very precise form, where you can count very clearly as the different colors follow in sequence, or when they play in chords again, or in a clear beat of 3 or 4. I play such things, and the Zeitmaster now lives from the breathing of such variable structures. Why do I say variable? Because they are so-called, what I call in this time, time symbols. Words which I borrow. Let's say there are these different instruments playing at the same time. Let's see. The other one's playing. I leave it with you. And what's happening in a certain amount of time, an interval of time, can change because someone can be ahead of another. And I have to calculate when I compose the relationships between the different pitches, that everything within a certain amount of time can move, is flexible, is variable. It can vary. And that time when the song runs over the music, always with a certain width. Sometimes it becomes more narrow when it's more determined, the music. Sometimes it becomes more wide when it's more indeterminate, the music. More variable, the music. And then what happens inside is varying from performance to performance. And they must count with this variation, with this interchange. So when I would just say stop, and now I would say stop, then the time will eventually is half an hour long. When they can play anything. If there is no control of meeting again, or of the pitch relationship, so that time slip or time window through which I hear the variable characteristics of several layers running at the same time has become more and more important. That's variable music, and I play you now the section from Zeitmaster. That works by playing as it lives from that breathing. The instruments leaving the common time, going on in the same in individual time, and meeting again. And this now, not always all together. Sometimes one is off time, he varies a lot in relationship to the others. Then 2, then 3, then 4, and then all 5. There are sections where all 5 have individual time. So there is a continuum between complete determination and extreme variability. And that's also the way we listen to it. We feel this. When it's very, very determinate, then we know exactly where we are. We have a certain beat, we are in a certain sequence of colors, and we can analyze exactly the rhythm. But when we are in a region of high variability, the music is floating. Now the word statistical is new in the context of music, naturally. It's borrowed from other fields. One example, we were asked to seminars of Professor Mayapel, random text. Let's say he would give us, according to the principles of what he calls Markov series, just individual letters, and say make any text with chance operation. Then he would give us individual syllables, then individual two-syllable units, etc. And we had to try to find out what we call the degree of redundance is of the resulting texts. And he was a teacher who came from phonetics, from the field of phonetics, which means the simple analysis of the different sounds of the language led him to the studies of statistics, because he wanted to know more precisely what all the different noises are. Analyzing the wave structure of the noises led him to the methods of statistics, to describe them and to analyze the consonants in language. I give you now an example of composition which is worked out with degrees of different indeterminacy, with degrees of statistical behavior of certain groups of elements, groups or masses of elements, points of elements. That means that the variability, which was here the result, as an intermediary state between determination and statistical behavior of sounds, groups, and masses, that the field, the variability was based on lines. I gave the example where you could follow the lines very well, because one instrument was playing a whole sequence of notes, and just following the color of the instrument, you were able to follow the different speeds. Whereas in a statistical composition, the field becomes very wide, and one cannot follow precisely lines. So I give an example from cycle per percussionist, for one percussionist. And in this cycle for one percussionist, there are certain events which are clearly periodic. And they show by their being periodic, for example, accelerando, that they are not statistical, that they are determined. When I do dum, ding, dum, 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 that is certainly not statistical. Because statistical means that you can permutate, change the order, without that it really matters. Whereas when I change the order of the text that I have just produced with my mouth, then there is no longer direction, no longer determination. It makes, for example, and afterwards I make it doesn't really matter, because there is no direction. It's just an irregularity of distribution of small groups. So please listen now to the following composition in these terms. Whenever you hear something that has a direction, for example, you hear a cowbell drum cymbal, cowbell drum cymbal, cowbell drum cymbal, triangle. Through that repetition, there is clear direction given. Whereas in others you hear cowbell, cymbal, triangle, guero, guero, triangle, guero, cowbell, cymbal, etc. No direction. And that is and it is clearly composed in that way. Then, for example, there is a system where you have these notes which are in an actual random until there is a change of direction. That is clear direction, like an arrow. Determination. And on top you have, let's say, over that time period, you have a box, which is like this. And in this box, you have different elements, and it says distribute these elements in any order. This would be with the tam-tam, and this would be with the cowbell. And there would be another element of that length, which would be, let's say, with the triangle. That's it. and distribute them in any order, and repeat them, let's say 5 times. I mean, not repeat them, use them all 5 times, in any order. So the degree of statistical composition changes in such a composition between very small time field and very few elements that can be distributed up to a very large number and a long time field. There are many different degrees, and I have worked with a series of 9 degrees of statistical distribution. I'm not saying that there's close to find these 9 degrees are, but the music that is the result of such a method has very particular characteristics compared to another music, and that is what is important in the context of this talk. We have used, since the introduction of statistical methods into musical composition, the term of the band and of the width of the band. That means whatever the determination is, let's say in pitch, highest pitch, lowest pitch, or in rhythm, smallest, shortest duration, longest duration, or in timbre, the brightest hues timbre in a certain texture and the darkest. What is in between such limits is called a band, and the band has a certain width. When the width of the band is 0, then we have a highly determinate situation. Then there is no choice. And when the band is widening and finally going over the whole range of possibilities, in pitch, when I can say, for example, any pitch, then it's the band width is maximum. So between extreme determinism and extreme relative indeterminism in a given composition, there are all the degrees composed in terms of the different widths of bands. And some composers have, since the statistical methods were introduced, completely specialized in statistical composition. For example, a man like Xenakis, or to a great extent, a composer like Ligeti, or also a composer like Penderecki. They became famous because they just specialized on one aspect. And this happens every once in a while in music as well as in all the other fields, that someone specializes on one new aspect of the field of forming. Let's say like Mark Tobey would specialize for years and years and years on certain microstructures, textures, let's say. Or like Ligeti on band composition, or Penderecki on clusters. They become cluster specialists. Like in other contexts, let's say the American Feldman becomes a specialist in music that is as slow as possible and as soft as possible. We have these specialists every once in a while who specialize in one very narrow field, then go very deep, and they vary it all the time. You know this in painting even more than in music, that someone has so-called style, personal style. What we mean by that is that someone narrows himself completely so that he can be identified when you even see a little bit of him, of his work. Then you can say, aha, that's Yves Klein, it's blue. And we can really say that universalists are becoming very rare in all fields. Very, very rare. You have mainly, like in all the fields of science, or like, let's say medicine, so you have people who specialize on part of a limb, and then do nothing but that. I always say the students who are studying with me, if you want to become famous, they just take a lens, an optical lens, and put it on one of my scores. And what you see through it, you just multiply it for 5 years. For example, if you and you start composing about 20 pieces, only with snare drums, of all different sizes, for 50 snare drums, for 20 snare drums, for 30 snare drums on a roof, snare drum in the basement. Yeah, I mean, snare drums, really, and very tiny snare drums. And then snare drums amplified, ring modulated, snare drums. Then he will be the snare drum composer. And he will be known in Japan, he will be everywhere. You can specialize in anything, or let's say trill. Just become a trill composer. It's very easy. Or the crescendo composer, or like I say, the pianissimo composer, or the as soft as possible composer. Or the cluster composer, what have you. So, I come to the last set of terms. We have traditional terms like development, of sequence and moment. Just a few musical terms. Development, more and more. In the first movement of the sonata forms, the thematical development. The theme, and increasingly reduction of the number of themes. There were compositions with 3 themes, 2 themes, even sometimes one single theme. Leading to the extreme, historically, that Schoenberg said as the ultimate statement of what he wanted to do, as he said, everything is development. And he had that idea, as well as Matthias Hauer, another obsessed Austrian, saying that he just wanted to work a whole universe just with one formula. And then it was not in vain, all very close together historically, when scientists announced the Einheitsformel, the formula that would be at the basis of the whole universe. You know that this word has been in the air. Heisenberg has been related several times to the Einheitsformel, to the unifying formula, etc. It's in the air. Everything is development of one thing. That's what Schoenberg said in one composition. The series, for example. Or a series of proportions. I said during the first works that I composed. I have written the word dramatic underneath. And when we hear the word dramatic, we always think something emotionally loaded. That's not necessarily true at all. Dramatic means you present figures, people, like the Greek drama, develop, and then develop. Lead these figures through all through different kinds of experiences. One gets killed, another one gets married, and the third one gets sick, another one goes to America, etc. Not in a Greek drama. It's a little early. But yeah, I mean, things happen that way. So and then he reoccurs, he comes home, a lot of things happen during the course of the journey, etc. Dramatic means that you can always follow the red thread, even if you lose it sometimes. That even increases the dramatic force, the tension. But then, in music in particular, in Europe, in classical time, the music had to represent the general interpretation of the universe. If the end is good, everything is good. So there had to be the recapitulation at the end. And then, everybody was pleased, no matter what had happened in the meantime. There had to be an optimistic end. That was in music the case, not so much in the drama. Whereas it has something to do with the classical time, naturally. In Goethe dramas, we find that too. That ultimately the good force, etc., was coming through. But there are a lot, and in particular in England, you know that from Shakespeare, and where the dramatic composition was made in a way that the figures, the drama was naturally finished when everybody was killed. And then there was a natural end. Conclusion was determined by the fact that they could not get out of the tomb and start all over again. At that time. So we have quite a lot of musical compositions which reflect this concept of how to interpret the evolution of the universe, and this comes certainly from the Jewish Christian tradition in our work, because there is that beginning and that end. It has very much to do with the interpretation of the arc of development.